Okay, Math 3, SBAC review. Today we are talking about linear regression and lines of best fit. Some of you have done lines of best fit already in your science classrooms. Do you guys recall this? So, some of you have a set of data. As you notice, this right here is not actually a line. They are points on a graph, and we can make a line that would make like the best fit line, okay? By doing a line of best fit, we're able to predict what could happen in the future, okay? So, exercise 1. A pediatrician would like to determine the relationship between infant female weights versus their age. The pediatrician studies 100 newborn girls and finds their average weight at the end of 3-month intervals. The data is shown below on the scatter plot and then on this table. Okay, so using a ruler, so you can use a piece of paper, your ID card, whatever. We want to draw a line of best fit here. Now, when you're drawing a line of best fit, they tell you that you want there to be as many dots above the line as there are below the line. Okay, so I'm going to try my best to draw a line of best fit.
You trace the dots one by the first one.
So you'll see on here that some of the points are below the line and some are above. I didn't really draw a great line of best fit because there's only one above and there's like a couple below. Yes?
So a line of best fit is just one line straight across?
Yes. Now, we're going to actually see how to do this in the calculator later, but we're going to talk about it first. Now, we're talking about linear lines. What is our equation for lines?
Y equals mx plus b.
Very good. Okay. Y equals mx plus b. Okay. Now, based on this information here, on B, by picking 2 points that are on the line, they're not necessarily data points though, but they are on the line that you've drawn, determine the equation for your best fit line. So, y equals mx plus b, there are 2 pieces of information that we need in order to write a linear equation. M stands for what?
Slope.
Slope, and b stands for? Y-intercept. Okay. Does anybody know how to find the slope? Do you remember the equation for slope? Okay. So slope, which we call as m, is y2 minus y1 over x2 minus x1. So we're going to choose 2 points on here. The first point I'm going to choose is right here. Notice it's not an actual data point, but it's a point on my line. And the ordered pair for that point is?
512.
It's actually 514. These are going up by 2s.
Oh, okay.
So that's 514. Okay? The other one I'm going to choose, and if I had drawn it better, it'd actually be on here, is 1020. And maybe that one's on yours the way you drew it. But basically, when you're choosing your points, you want to choose points that are on the line you have drawn, but they don't have to be data points. Okay. So if we're finding the slope, we can label these as x and y and x and y. And to find our slope, we will take 20 minus 14 over 10 minus 5. 20 minus 14 is
6.
over 5, and we're going to actually make this a decimal, and that is a decimal of 1.2. So I have my m value. Do you guys have questions? Are we okay? All right, so this is my m value. Both of these answers are good, but for today's lesson, when we're going to be graphing these on the computer in a calculator, they're not going to have them as fractions, they're going to have them as decimals, which is why I changed it to this, okay? But both answers are good. How do I find my b? Who thinks they know on how to find the y-intercept, the b value? So if I'm writing my equation right now, I would have y equals 1.2x plus, I need a value there. How could I figure out what that is? Plug in one of those points. And this is my b, my missing value, and I can solve for it. Okay? So, let's use 5 and 14. I'd write this as 14 equals 1.2 times 5 plus b. 14 equals, what's 1.2 times 5? 6 plus b, and we subtract 6. And so 14 minus 6 is 8. 8 equals b. So my equation for my line of best fit is y equals 1.2x plus 8. So now we are going to end up moving to our computers, and I'm going to try to project this as well. And I want you to go to desmos.com, or if you type it in Google, if you type Desmos graphing calculator, that's where you want to go. Okay, at the end of your notes packet, if you like to go ahead, I have typed out instructions on how to deal with this. And it doesn't look like it's going to connect for us here. So, hold on just 1 minute. I'm just going to put it under the screen. Okay, so sorry about the reflection. That's just the way it's going to be. Okay, so at the end of your notes packet, I said there's instructions. What happens is if we want to find the actual line of best fit, we can use this calculator. And on the SBAC test, this is the calculator that's going to be available to you. In order to do a line, the first thing you have to do is make a table. So if you go up to this plus sign right here, we're going to make a table. On the top left hand. Is everybody okay there?
Yeah.
Okay, now I find the easiest thing to do is go in and put all of my x values, because I can just enter down and then put all my y values in. So I'm going to use this table. I'm going to type in my x values. So I have 0, 3, 6, 9, 12, 15. Then I'm going to go to my y values here. 7.2, 12.2, 15.1, 19.4, 21.5, and 26.3. Okay. Now, depending on, some of you can see your points and some of you might not, but do you see on the right side how you can do plus and minus? And you can move the screen. But so it's over here on the far right side of your screen. There we go. You have that plus and minus tool, and then you can move things around. And okay, so we have all of our data there. Okay, so now we're going to find the line of best fit. Are you guys ready? So on the number 2 here, you need to write y, and then there's the tilde sign. You can find it by typing or pressing the ABC button. And then if you see it's on the bottom row, the second from the right. Oh, and you know what? I forgot something. We need to put Y1. The reason why I'm putting Y1 is because in my graph, do you see how that's or my table, see how it's labeled as Y1? Okay? And then we're going to go, how do we write, what's the equation of a line? Okay, so I'll write it on the board here for some of you too. So we're going to end up writing this equation. Y1 tilde m and then x1 plus.
How'd you get the tilde?
So you press the ABC button, which is in the bottom left. And again, these instructions are at the back of your note packet. So I'm going to put M and then X1 plus B. And do you see how a line has now been drawn on your graph? Yes? Okay. Now, if you look over here, it's telling you that M equals something and B equals something. Do you guys see that? If you go back to the data that we wrote down, we had said that M equals what? 1.2. What are they saying M is in the graphing calculator?
1.2.
1.2. The B they're saying is 7.8, and we said it was 8. So are we pretty close with the one that we did?
Yes.
Yes, but was typing it into the calculator way easier than trying to do all that by hand? It actually is, and we'll practice more with typing things in. But what I would like you to write now is, and I'm going to move my thing away, back to your notes page. Using the regression calculator, we wrote, and go ahead and write this down here. Y1 is approximately equal to mx1 plus b. The equation we got was y equals 1.2x plus 7.8. Now, it's pretty good. It says use your calculator to determine the linear correlation coefficient. Round to the nearest thousandth. How can you interpret this value in terms of the variation in weight due to age? Okay. There is a value on there that says R. And to the nearest thousand, it's 0.995 is your R value. This is talking about the linear correlation. Okay? Now, what happens is, basically, in a linear correlation, we have a -1 to 0 to 1. If your R value is close to 0, there is no correlation. Basically, it is a bad equation because there's no correlation. Based on the data they have, they've given you this information, but it doesn't work out right. So here what they're saying is when you use this equation, you're going to get pretty close to those points every time. Like it's a good correlation. Okay? So if you're anywhere like close to -1 or close to 1, that is a good correlation or a good equation. So anything that's close to -1 or +1 is a good correlation. Are there any questions so far about what we've done? Okay, we're going to turn to the next page. This says, using the equation that your calculator produced in exercise 1, predict the value of a baby girl after 10 months. Well, we could do the math, but we have a calculator. So, let's figure out the answer to that by using our calculator. So, if we want to find 10 months, what do you think I'm going to do? Oh, that would be one way. Let's try it. But let's see if that actually gives us a value. The one thing that's nice about like these calculators is you can try something and see what happens. Did it give me a value when I put 10 up there?
Can't see it.
Oh, sorry.
Wow.
When I plugged 10 in, did it give me a value?
No.
No. Okay. Do we have an equation? Did we write an equation?
Yes.
So, what we're going to do is use our equation to find the answer. So, y equals, what was my m value? M was 1.2, correct? We're just going to round it to the nearest 10th. Now, it's after 10 months. So our X value is what? 10. And then our equation, the B value was 7.8. And then look, it gives us the answer.
19.8 pounds.
Exactly. So at 10 months old, the baby should weigh approximately 19.8 pounds for a girl. Okay, ask me a question. So we were able to write our equation based on this information. Okay, so the exact M value is that. We're rounding it to the nearest. Sorry.
It wants you to create an account for a calculator.
You don't need to.
Why? It's just a calculator.
Okay. If you create a count, it'll save all of your work for you. So then if you didn't want to retype things in later and you wanted to save it, you'd be able to. Okay? All right. We are going to skip down now. Okay, so now, let's say we want to see how much I weigh. Okay? So based on this prediction model, okay, currently I'm 38 years old. How many months am I?
38 times 12. 424. 3.
I'm 456 months old, okay? I'm actually closer to 39, but we're just going to go 38. So if we use this model,
You were 20.
thank you.
You're welcome.
Y equals 1.2 times, so how many months? I'm 456, okay, plus the 7.8. It is saying that I should weigh 555 pounds.
It could.
Okay.
Big country. It's right.
Now, in case you guys didn't know, this is not correct. I do not weigh that much.
You should. Really?
Okay? But this, we're going to talk about like correlations and stuff, but this only works up until a certain time. Like right now, throughout your life, you're growing at a certain rate, and then there's a time where you shouldn't grow anymore. Okay? So, there was a certain time where I should no longer be gaining that amount per month, right? I should not be gaining over a pound per month.
We can plug it in for a while.
Okay, so I just want you to be aware that this doesn't work all the time, does it? There are normally parameters on data. Yes, Max?
Can we plug it in for Y and get a rough estimate of when you stop growing?
We probably could, but we're not going to do that yet. Okay, so based on the information that I was just talking about, there are two different types of ranges. Okay, the first one is interpolation, and that is within the range of the known data. Okay, interpolation is within the range of the known data. Then there is extrapolation, which is outside the range of the known data. So, on this question that we had previously talked about, we only knew data from 0 to 15 months. So if I said 10 months, which we did, that was an example of interpolation, okay? When I said, let's try to figure out my weight, that was outside the data, which is extrapolation, okay? Now, we're going to do another exercise. The nice thing about this one is that we're only going to use the calculator. We're not going to do any of this by hand. So, here we go. You're going to go back to your calculator. Okay, and the first thing I'm going to do is just exit all of these out because I want to start over. In order to find the line of best fit and do linear regression, you have to first make a table. Okay? Now, notice here how this was x1, y1. If I kept the data in and I made a new table, it'd be x2, y2, which means when I'm writing my equation, I would want to write x2, y2. So make sure that these match the equation that you're trying to get. So right now, let's go ahead and input this data. Everybody should be doing this. I'm going to start with my x values. 22, 24, 28, 34, 39, 42, 48. Oops. You can just press enter. After you type in your number, you press enter and it goes down to the next one. Or the down arrow. Okay, so now I'm going to the y's. So for the y's, the first one is 3.43, 4.46, 7.08, 14.21, 22.19, 31.22, and 35.67. Okay. Now we want to find the line of best fit. Do you guys remember what to type in?
Our equation.
Okay, how do I write it?
Y equals AX
Nope.
Y1 equals A1.
Y1. And we're not using A, we're using M. You could do whatever you want though. You could write an A if you want to. I'm going to go ahead and stick to M. Okay, Y1, and then what do I do? Do I do equals?
No, you do the squiggly line.
Good.
The Lagon, what's it called?
I think it's called a tilde. Is that?
Yeah, it is called tilde.
Okay. And then M, X1 plus B. And it gives me my information. So, first of all, looking at our R value, is this a pretty good equation?
Yes.
Yes. It's pretty close to 1, right? That's good.
Even if I was negative, that'd be good, right?
Yeah, it would just be, instead of increasing, it'd be decreasing.
Okay.
So that's the difference, okay? Now, so based on the information, I'm going to try to write on here, and my notes, on A, what is my equation of the line? Y equals, what's my n value to the nearest tenth? You guys should have it on your screen.
1.33.
Good, 1.3 x from my n value here. And then the b value is going to be what?
It's negative 27.9.
Oh, it says to the nearest hundred, sorry. 0.98, and then this one would be 0.32.
Delta.
Okay,
Wouldn't it be 3.3?
Apa dapat delta?
5.
yes, it would be 3.3. Another candy for you. Okay,
Jesus. Delta.
He's getting a lot of candies. Jesus has nothing to do with it.
exactly. Okay,
This is my dad.
now, on part B, it says using the information from part A, determine the expected weight of a salmon that is 30 inches long. What's the easiest way to find this answer?
Plug in 30 for X.
Okay, so we're just going to go here. We're going to plug in 30 for x using our equation. Y equals, my m value is 1.33 times what?
30, but 1.3.
Oh, thank you. Sure. And then we have minus 27.98. What's my answer? 11.92 pounds. That's your answer for B. Okay, on C, it asks us to find for a salmon that is 52 inches long. So what are we going to do?
Mine is 7 is 52 inches long.
You can't do that.
Could I just put this in here and just take this out and put 52 and not even retype it?
41.18.
Yes, I can. Okay, now here's the big question. On D, in which parts, B or C, did you use interpolation, and on which part did you use extrapolation?
In B we use interpolation, and in C we use alpolation.
Okay, that is B, and this one is C. And why is that?
Because
Extrapolation is
extrapolation.
good within the data and outside the data. Okay, we are moving on. Okay, now we have been doing linear regression, which is dealing with lines. Guess what? There are other types of regression.
Can we just drop it?
It's not bad, okay? This, what do you think? Is it exponential or quadratic?
Exponential.
It's horseshit.
Okay, and is it positive or negative exponential?
Positive.
Good. How do you know it's positive?
Because it's increasing.
It's going up. This is what? Good. Negative because it's going down. What is this one?
Negative exponential.
Okay, this right here?
Is exponential negative. That's a linear negative.
Linear. Negative. This one is? Good. Okay. And the last one over here?
Positive quadratic.
Good. Okay, I'm going to turn the page. I'm going to wait. Are we good? Okay. So we have some more data. Okay? Let's go ahead and exit out of these screens in our Desmos and
Exit out of the
we want to start with a new screen here. New table, thank you. So, new table, let's input the data. So we have 0, 1, 3, 4, 6, 7. Okay, starting at 0, it is 16, 18, 22, 25, 33, 35. Now, this is where you kind of want to look at the data. And you can't see what I see. So it looks something kind of like this right now. But if you go into there, they're saying it's actually exponential. This almost could be linear, but they're saying exponential, okay? So they are telling us how to write an exponential linear or exponential regression. Are you guys ready? Do you see it written on the paper here? Okay, type it in. See if you can figure out what this equation is.
Your phone's ringing.
Y1 Matilda. How it looks like. Hold out my nose.
You can go now or later. Okay, did you guys get it? So y, wait, what do I have to have with the y in order to make it work?
Y1 Matilda.
Y1. And then they said A, B, and do you know how to make B go to, and then the x to go to the exponent?
Yeah.
You click A squared.
Or if you, on yours, if you go shift 6, because you have that little caret thing, it makes it go up as well. So that's just a shortcut.
You can click up on the arrow.
Wow, Miss Alto. Thanks for that.
You're welcome.
I'm serious.
Yeah, no, I'm serious. You're welcome too.
Do we do
Okay.
X to the 1?
Yes. So your y and x always have to have a 1. Or if these numbers here for some reason were 2s, then you would make those 2s.
Oh, okay.
Okay?
Okay.
All right, so can we write our equation based on the information they've given us?
Yes.
Okay? First of all, does it... Are you guys ready? I'm going to move this. Okay. Oh.
Wait, why didn't mine equal to some beast?
Not really.
Can you show me yours again?
Yeah.
Yeah, Y1 Matilda. Oh, is that...
Push shift 6.
Did you figure it out?
There we go.
Okay, so you guys have the information in front of you. Okay? The equation. What is the A value?
A is 15.9.
Okay, we're going to go 15.92. What is the B? 1.12 to the x power. I'm taking that equation and I'm finding the information for my regression equation to write it here. Now, it says based on the regression equation, how many total cases of flu will there be after 2 weeks? How many days is 2 weeks? 14. So again, we can use this equation and put 14 right here. Okay, and you can do that in your calculators. And when you do that, you should end up getting what answer, or what do you guys get?
Exactly.
So I use my equation right here. Y equals,
You get 80.4.
I got something different. 15.92.
I got 7.
I didn't round my star.
I'm gonna say
Why is mine?
And then,
Type them out
right
replace.
there.
so make sure that you do that as an exponent. Your 14 needs to be to the exponential power. You also want to make sure that the 14 is only touching the 1.12, which is why I put in parentheses. Okay, so how many cases will there be?
77.8.
And so we would round that to be
78.
78 cases. Okay, now this goes back to what we talked about last week with exponential growth and decay. And that is, with this equation, do you guys remember how with our equations, if I said it was decreasing in value at 8% per year, what did we multiply by if it was decreasing by 8%?
0.92.
Good, 0.92. Okay, now on this one, what is it multiplying by?
1.2.
So this one, is it increasing or decreasing? So anytime that multiplier, that 1.2, is greater than 1, it's increasing. If it's less than 1, it's decreasing. And you know the percent it's increasing by how much bigger it is than 1. And so what percent is it increasing by? 0.12, which is actually 12%. Does that make sense? So if the multiplier was 0.97, what would that tell you?
It's decreasing by 3%.
It's decreasing by 3%. So right here, by what percent is it increasing daily? It is 12%. We get that from this 1.12. It's 1 plus 0.12. That is what it's increasing. You're taking the whatever it started with, which is the 1, and 0.12 is being added to it, which is the 12%. Okay. That's it for today.